All right, we're on. It's yours, Roy.
Excellent, thank you. So this session is for thinking about properties of the latest project on of a Starknet bridge. And we would like you to participate on the ideas you have for this project and for this system. After I guess you've been dealing with the Certora spec and thinking about rules yourself. So what we're going to do, we're going to work simultaneously with some Google Docs file in which we're going to think about properties and write them. And afterwards, we're going to share this this doc with you so you can just have all the ideas of your combined. Before that, I'd like to address a question on Discord that just popped up. So let me just say what it was. Datapunk was asking, in a real setting, what should a user expect if he or she calls withdraw or receive rewards from L1? Should it revert? Thanks. So the original implementation of this one includes messaging contracts and messaging functions, which we ignored, as I explained in the last session. However, if we do want to refer to that implementation, so the messaging contract or functionality should make sure that only sent messages could be accepted by either side. So yes, any user can actually call withdraw or receive rewards, but if we trust the messaging contract to be well functioning, we would expect that if the message was not sent, meaning the payload for that message is not accepted, meaning the exact values of the amount or the messenger or the receiver, so this should revert. And regarding who can call it, so anyone can call it, actually. So if you want, for example, to withdraw your tokens, so you've called the withdraw function on L2, and then you would like to do it on L1, so anyone can do it for you. What we would expect that no matter who called this withdraw, the tokens will be given to the right recipient, to the rightful owner. So in this case, for the old implementation, yes, anyone can call them. But in our implementation, we've created like a safety guard that one cannot just call them simply, but one has to go through the L1, L2 interface. So anytime you get a function or a rule in which these were called, you should actually ignore them, or you can get unreachability. These functions will be called only through L2. So I hope this answers your question, Datapunk. If not, you can continue this on Discord. And Himanshu was asking as well if it should revert, why not add a modifier like only L2 bridge? Because we wanted to keep the option that anyone can call it, but we've made similar modifier. We've created a modifier which you can look at it in the code itself, that only sent messages could be accepted. So it is, I think, the only line in this function. Okay, any question on this last explanation? Multiple times with the same payload.
Yeah, like spoofing. I mean, you receive a valid message, just like replaying a message, right? So you see a message, and maybe that's because I don't really understand how the messaging works in this case between Starknet and Ethereum. But then if you receive a message that is valid, and if I can see that, can I replay it? Presumably it has a nonce, and there is that the defense mechanism? I'm not even sure if Jonathan, is that your question, Jonathan?
Yeah, that's it.
Replaying. Okay.
About multiple calling with same payload, like I can withdraw twice or something like that.
Roy, are we still on?
Roy, have we lost you?
Oh, he's okay.
Let's give him a. I think this is well, should be a good property. I'm not that familiar with the setup we have done, but I'm not certain that this. Well, I think thinking about it again, because there's like the transferring of assets. You should be. I think the consume message is only checking that this came from the bridge, and if the same message will come twice, it should be actually two different transactions, right? So so that's the way we model that we trust the L2, that if the L2 is the one that is the message sender, then it will not call with a message that is a replay, I guess. But basically, it's a good property. I think even this setup should obey this property. That's what I'm saying.
Okay. And maybe, so I think there's a trusting the L2 to not sort of replay the messages. So if that is outside the threat model, then maybe the one that could be within is if anyone is allowed to call withdraw, as Roy was mentioning. And if I'm able to monitor the messages that have been accepted, then once I see this message in a transaction, it gets consumed and the withdraw happens. Can I replay it as an attacker by directly calling withdraw with? I'm not even sure if that is possible, but that is probably the other scenario where it doesn't have to be the L2; it can be someone else.
Yeah. So I think because there is a require that consuming a message actually means that the L2 is the message sender.
Sender. Okay.
It's actually, I mean, I guess. On the real code, it will be something like, okay, this message has been signed by L2, but we don't have a way to model that, or we chose like a very simple model to say that this just came from L2.
Got it. And I think for the scope of this, the verification, the messaging part is outside the scope, right?
Exactly.
So this would probably fall in that.
Yes. Yes. And also the Cairo part. So all of the L2 is actually modeled as right in Solidity instead of the original Cairo code. So there are. I hope I hope it's correct. One of the things that is challenging is actually writing a correct representation, especially if we cannot verify it that it's equivalent to the original code. So sometimes we do have simplifications, or we have an over approximation that represent what is actually in the original code. Like the very basic one is like price. Price can be any value. So it's cover all the cases. It's an over approximation probably, but it's a safe over approximation. When we actually model the external contract, we might make mistakes, and it's part of like the verification. We might find out that actually the bug is in the harnesses.
Got it. Sounds good. Let's see. I think there's a related question on the chat. But Roy, are you back? We saw you toggling mute and unmute.
I wasn't muted. I think there was a technical problem, but I can see
Okay.
that now that you can hear me. So,
Yeah.
Got it.
are we referring to Parth Patel's question? What does the following line do? And I suppose that the consume message from L2 does nothing because we don't have the contract of this messaging contract. This is something outside the scope of this project. But I'll repeat again how we model the system. So we're ignoring any messaging between the two sides, and we're just letting all the functions to be called directly between the two sides. So I would like to say that this contract or this function is actually empty. The only thing it might check, if I don't remember the implementation exactly, but the only thing it checks that the sole caller to these functions would be the bridge on either side. So I hope this answers your question. And if there are other, I'll be happy to explain. If not, let us try to think of properties. So what I will do is open this doc file, and I'll try to write simultaneously as you suggest your properties. So let me see what I can share. Okay. So this is a very common way we write properties. We try to classify them to different meanings or different categories. Usually we like to think of high-level properties, and these are like the properties on as we look at the system as a whole, and we try to write or express things without referring to actual functions, without referring to unit testing or a very specific procedure happening inside the system. And then we have more specific rules, like rules about deposit, withdraw, and this contract static A token. So we gave you an example for each of these categories. And I think we can start a discussion. Each participant can offer its property, and we'll discuss where it should belong to. And then we'll see if we can try to implement this together inside a spec file. So any volunteers on some property they thought about? Don't be shy. It's a open discussion.
All right. So maybe I can start, and I don't even know if this is a valid property. But and I'm not sure I'm thinking, Roy, in the sort of the framework that you're displaying, right? In terms of, even in terms of like the unit testing, parametric rules, I think the categories that you have, 6 categories. I wasn't thinking that way when I started taking a look at the contract. I was mostly approaching it from from the perspective of doing a manual review, right? Which is what I'm used to. So when I started taking a look at bridge.sol, which is where a lot of the code is, right? And the first one obviously is just going top down, look at the modifier, but then going to the initialize. One of the things that auditors immediately start thinking is, okay, this is an initialize function. Can it be called only once? And in this case, there is that initializer modifier. And I was wondering if, that is a property. I mean, and this is also in the spirit of not actually looking at the implementation before thinking of the rules, right? So if I do not want to assume that this has an initializer modifier, can I still verify that initialize can be called only once, right? So that is something that I started writing. and it's not verifying. So what I did was I called initialize, and then I called initialize with revert immediately after that, and then I was trying to assert on the last reverted, right? Assuming that the initializer modifier would kick in and it would make the second call to initialize fail because of that modifier. Is that and given that it's failing, I don't know why it is failing. I haven't had a chance. I just started writing down some abstract rules at a high level. But is that something interesting that is usually a rule in your spec?
Yeah, so absolutely, this is a good property to think of. Sometimes the modifiers don't restrict is the way we would think. Maybe we'll go into the code to see what the modifier was.
Sure. You want me to share it? Share my screen?
I'm looking at it independently, but if people want to like see it as well, so yeah, maybe I'll stop sharing my screen. Go ahead, Rajiv.
No, we can. I mean, it's as simple as I said. Let me see if I can share that. Okay, give me 1 second. Or, I mean, if you want to sort of discuss all the rules and sort of write it down, and then we dive into each one. I'm not sure what flow you had in mind. Do we go?
So I think that mentioning the rules and explaining them is enough just for us to brainstorm our ideas. Maybe later each one on his own can like see if this property is a trivial one, or can we actually prove it or not? Because they want us more rules or more properties to be said here. So commenting on your property, I think it's a good one. Also, what you've suggested that one should not look immediately at the code, but only look at the interface. This is a good approach, because looking at the code sometimes we restrict our thinking, or we're not thinking outside the box enough, because we're looking at a specific implementation. So in a very natural way, we're trying to write our rules based on what the function does instead of what the function is supposed to be doing. And I would think that anyone just as looking at the interface and understanding how the system works will write better rules than just looking at the function implementation, and eventually we'll write unit testing. But this is not the best type of rules we would want. So yeah, definitely I would write this. Any more suggestions, Rajiv?
Sure. I mean, just in that function, and this is, of course, I did take a look at the function implementation. So one of the natural things that sort of pops is, given that it's initialized and there are a whole bunch of address parameters, have all those been sort of zero address validated, right? And in this implementation, we see that incentives controller there is a require to make sure it's not zero, but then we don't have similar checks for L2 bridge or the messaging contract, right? Which could potentially lead to reverts later on. So so for that. Yeah, I mean, that's the second one, and I did implement that, and it seems to be failing as expected. As in, if I force the messaging contract to be zero and then I call initialize, I get a revert.
So just to make sure I understand, you're suggesting that the L2 bridge, if it is a zero address, then the function should revert.
Sorry, not the L2 bridge. Well, that's a UN256, but the messaging contract.
Yes, absolutely. So this is another issue we're having many times, that we write a property and we suggest when we expect it to hold, for example, a property that a function should revert, but we're not getting the expected behavior. And this is because the prover can also make counterexamples which are infeasible. So regarding your example, we know for sure, as long as the constructor was called beforehand by in a logical manner. I mean, if we look at the constructor, I guess it's supposed to be somewhere. Maybe there isn't a constructor. Hold on. Oh, sorry. This is like, okay. This is mimics the constructor. So yeah, I was wrong about that. Okay, we would expect whoever calls this initializing function to put the right address.
Yeah.
And had I given a wrong address for the incentive controller or for the messaging contract, and afterwards I would call any function using this contracts interface, I would probably get a revert based on my knowledge and solidity. And these are things that I will catch very quickly. But we should bear in mind that whoever calls initialize or any constructor does it in a proper way. It's a very, I would say, a good assumption, because we're in handling, I guess, with professionals and not people who just randomly insert values inside the functions. But I would not disqualify this as a good property, because of course we need to check our inputs always. We can't really rely on anything. But you would agree this is not a strong property as, I don't know, calling L1 token, which does not exist at all.
Right. Yeah. I mean, this is typically, you know, it's like an informational rating, right? Where I mean, it's just good hygiene, software practice to actually check if none of these are zero. Because if you don't check, then, you know, in this case, we'll have to redeploy the contracts, and typically your deploy scripts take enough care that they are non-zero and valid. So it's definitely not a very strong one, but I mean, that's sort of logically, when I look at the code, that's like, oh, they've done a zero address check for incentives controller, but, you know, we're not doing one for messaging contract, right? So maybe there's a good reason for that, but maybe there isn't, and we actually it may be better to add a require there as well. So the property was that if I require messaging contract, the parameter, the argument to be zero, and then I call initialize, then it does not revert, which means that you know, there is no require in the initialize that is checking for the zero address validation. So that's a minor thing.
Yeah, absolutely, I agree. But just one thing I think to comment here is that this requirement for the address not being zero is then not enough. We need to require, I think, that the messaging contract is one of a very specific set of possible contracts, and not demanding it doesn't equal to some contracts, because probably this value for messaging contract is a very limited set of values which are okay. So the question is how to implement a requirement inside this initialize function that makes sure we're fetching the right address. And if we start by just excluding, you know, zeros address or EOAs, this will never end. So
Absolutely.
This is probably this is why they didn't do what you're suggesting. Got it.
Yeah. I think if it is, you know, if there is a config file somewhere, and if they have sort of a whitelist set of messaging contract addresses, then maybe yes, but I don't think that's the case here.
Right.
Yeah, I mean, I think those are the two ones that I had for initialize, and maybe I should let others take a crack at this as well. And maybe let me say one more. The third one that I immediately noticed in initialize was the approval part, right? Because that's where a lot of logic happens, where you approve the bridge tokens and effectively create the bridges between the L1 and the L2 tokens. So there's quite a bit of logic that's being implemented there in the approved token part. So I think there are a whole bunch of rules that can be written over there.
Yeah, sure. Do you want to refer to a specific functionality of approved token, or just in general that the addresses should be correct?
I was taking a look at it. So one of the other things, and this is, again, nothing to do with the semantics as such, but whenever you see two parameters that are arrays that are expected to be the same length, then it's better for you to check. And I think they do this check somewhere. Yeah, so on line 247, sorry, not 247. Where was that? Yeah, 229, right? So they do a
right.
228. They do a length match, right? So does it? I mean, this is again. I mean, once you take a look at the implementation, does it make sense to have a rule again that verifies that this code is indeed checking that their lengths are the same, right? So I mean, would it make sense to have a rule that requires their lengths to be different, and it calls initialize, and then you assert that it will get a revert? Does that make sense, or do you look at it? I mean, assuming you're not looking at the implementation, that's the right way to do it. But if I look at the implementation, I know that they have a require. Now, does it make sense to also have a rule that verifies that require? I think that's sort of a meta question I had for all these rules.
Yeah. So once you've looked into the implementation and now it is trivial, this check is being made. So this rule is almost a tautology. And these are not rules we're interested in. I mean, suppose you hadn't looked inside the implementation, so this is an obvious property, and this is like one of the first things I would think about in terms of unit testing. So writing this property just inside a list is really okay. But when you're coming to write things inside a spec file, we want to write the best rules as we can, and not just overload the spec file with some trivial or less, or I mean, closer to trivial rules that just by looking at the implementation, we can be 100% sure that it's verified. So it's a point we should also emphasize, that the best rules are the rules that probably cover as much as function as they can, and cannot be simply inferred by one or two lines of code.
I can also add exactly on this type of rules that if you can, right, so you see this in the initialize, but then you might say, okay, but this might be updated, this to list. And then you want to say, okay, so whatever happens in the code, I would like these two lists to stay coherent. I would like these two lists to stay not just the same length. Like if something is 0, then something else should happen. And then you take it one step up. So instead of being a rule on the initialization, it's already a valid state rule that is checking the validity of the state on all the possible executions.
Got it. Got it. Okay, yeah, that makes sense. Thank you.
All right. Anyone else would like to offer property he was thinking of? Even if you're not sure about it. Okay. Jonathan Campus Martins is writing, is a good rule to check if initialize is initialized correctly, checking if matches. So this is like a unit testing rule, and it really is based on the correctness of your input. So I would say that this is okay, but again, this is the type of properties that you can only check if you know what is the intention or what is the input when deploying this contract. And this is not a thing we can we can really check. So it's really a question of, do we trust the deployer or we do not trust the deployer? And I guess most contracts out there will have these kind of properties. What I'm interested in is, can you make some check or write a rule that somehow checks that? Because you need to know what is the, I guess, the addresses in advance. And I don't think it's something we can rely on or something we can just add to our scope. If this answers your question. Awesome. Anyone else?
Maybe I can chime in with one more, and maybe this is another example of what not to do. But when I take a look at the approved token, right, the function approved token, so the actual linking between the L1 and the L2 tokens is being registered in the mapping _8 token data on 266. And then there is another state variable, right? We have that array approved L1 tokens, and we are pushing this L1A token. So a thought that came to mind was, okay, this should, I mean, if this is indeed being, I mean, this is probably one of the most critical parts, right? If we're establishing the link between L1 and L2, then there should be no other place, no other function, right, that modifies these two values. So I've not written this, but maybe this is a case for a ghost or a hook, right? I mean, maybe I'm wrong, but essentially what I want to say is, if this is modified, then the only function that can modify is the approved token or its caller initialize, and nowhere else in the contract should these two state variables be modified. Is that valid? Is sensible?
Just to make things clear, which value or state variable are you referring to not be changed but in initialize?
A token data on line 266 of bridge.sol.
Mm-hmm. So you're claiming that this should not be changed but in approved token?
Outside of approved token, yeah.
Yeah, so we can formulate this as, if this A token variable was changed, then it must have happened through the approved tokens or initialize in this case, right? Yeah, this is a very common type of rules. We write at Certora by checking, it's a parametric rule, by the way, because we're looking at the interface of the entire contract, and we call any possible function, and we would like to make sure that only the designated function should change this. And this is what we expect. I mean, don't want somewhere on the way that these A token data to be changed. And of course, this is a valid rule. And yeah, I would definitely write this one. I think it actually written in the spec in some manner, maybe something similar. We're verifying that once it was set, it would never change.
Oh, was it already there in the spec? Okay. Yeah, it might have
probably some version of it, but the idea is similar. I mean, we want this to stay constant. This is, of course, a valid property.
Got it. And how would you do this for a mapping? Because I think the typical framework is you have a getter, well, if you don't, then we have to write a ghost and a hook. So you check that, then you call the parametric rule, and you call that again. And if the value before and after are different, then we check that the function selector can be one of the approved ones, correct?
So I'm not sure you actually need ghosts for it. You can simply write a getter in some solidly harnessed function, and then check the values before and after. Ghost is only for something you can track explicitly by getters. but you can write a getter for this value or for this mapping.
Okay. Okay. Sounds good. Yeah, I mean, I think that's the last one I had for this, for the initialization part.
Okay, let's take a look at Himanshuvat, sorry for mispronouncing, rule. In case of deposit function in bridge.sol, it does not mint static A tokens in L2, but calls a function in messaging contract. So in context of harness version, does that mean deposit won't change the static A token balance? So I think in how our harness, deposit does change, because deposit calls the deposit on L2, which in turn mints static A tokens for that user. So I think if this is the rule you're referring to, that static A tokens should only be changed in balance through deposit. Does this make sense? Okay, good. So we agree that only deposit can change the static A token balance of someone. But just to give you a small thing to think about, what would happen if I would write this in a parametric rule and the interface would have also ERC20 interface? So for example, I would have access to transfer from, and what would you expect this rule to, the result for this rule verification to be? Because I'm calling any function that can do anything with the balance of static A tokens, and I know the transfer can change it. So sometimes the parametric rule by itself is not enough. Sometimes we need to filter the right functions or modify our assert in a certain way that regards only a certain subset of the functions we expect to be called. So it won't be a violation per se. It would be a violation outside the context of what we're expecting. Yeah, this is a good point to mention. Okay, anyone else by chat or?
I have a couple for
Yeah,
deposit, but I'll wait. Yeah, I think
Zarf?
that maybe, yeah, sorry. I was thinking about creating a rule regarding the static A token and the reward AAVE tokens on L2. But I'm not sure if it makes sense because it's all on L2 and we only had to test the contracts on L1. And we're now, yeah, if we test if we implement this rule, we're just checking the implementation of Certora, of the Cairo implementation, yeah, the Cairo part, instead of actually testing L2, right?
If it's solely on L2, so yeah, it would not check the bridge. You're saying that what you want to check is only inside the scope of the L2 harness function, contract?
Yeah, for example, one thing I was thinking of was if you don't have any static A tokens, you cannot mint any reward AAVE tokens.
Mm-hmm. So I don't think it is limited to only L2, because if we extend your rule and say that if we bridge tokens, then we can formulate this as, if I have a zero balance static A tokens, I cannot bridge anything onto L1. So maybe this is something you're also interested in. Is it?
Yeah, sorry, I was searching my unmute button. Yeah, indeed, that was a rule that I already written. So something like you can't claim any A tokens or underlying assets or rewards if you don't have anything on L2.
Right. So this is a good property. Let's see if we can first try it. So I would say, let me share my screen again. So given 0 static A token balance, one cannot claim rewards on L1. This is how would you?
Yeah, I think even more. You cannot claim A tokens, underlying assets, or rewards. No, but it could be wrong, of course.
Yeah, right. Because through the withdraw function, you're supposed to get A tokens or underlying based on your choice.
Yes, exactly.
But yeah, this is a very good extension. Okay. So it's not really well written or well formulated, but what I want to do right now is try to write this inside a spec. So I will move to a spec file, our original spec file. All right. Let's write this as 0 static A tokens cannot claim. So let's write this as just without any arguments and think what our precondition, our function, our postcondition should be. So what is the precondition? According to your rules, Arf. Can anyone tell me what the precondition is for this rule? Someone wrote static A token balance. But I hope you're seeing my spec file. So I would require
Yeah, we see it. Right, it's good.
Yep.
static A token. Okay, first let us declare some variables. So we'll use a very common pattern we used before. Let's just copy all this. Okay, so we have, say, one environment. These are the tokens. And this is our setup we've already used before. I remind you this says that assets and A token and static are a triplet of tokens that are related together. And in this case, we would want to claim that the static balance for that user is 0. So how to access the balance of static token? Let's see if we have already have a balance function for that. Token balance off. Excellent. So I would like to require that token balance off for environment E and static token for, let's say, a message sender is equal to 0. So far, so good. So we have our token and user setup, and we also have the precondition. Anything else I should consider, maybe? If not, I will move on. Okay, I guess not. Then we will need to call our function. So we will need to call the withdraw function on L1, which in turn calls the withdraw on L2. So let's see if we can fetch this. Okay. Let's just copy the arguments. A token amount would be, I guess, any amount. A receiver can be also, I guess, any address. Let's just see if this is a receiver in address or in uint. So yeah, I think this is in uint, which we'll need to use the L2 recipient value, which is given right here. And from to underlying asset, doesn't matter whether it's in A tokens or underlying tokens, because we want both. We're not going to restrict that in any. Okay. So the assert is the important thing here. Let's go back. So what the assert should be, just in plain words. Let's skip the actual writing for now.
I think the underlying balance before and after the withdraw should be the same, and the same for the A tokens. They should be the same before and after the withdraw.
Good. So just can write this as balance A1 before. Write a 3 dot here. Balance A1 after. Then we want to assert them equal. Okay, just to summarize this rule, we set up our tokens and user. We set the static A token or the corresponding A token to be 0 balance for that user. That user is calling the withdraw through L2. And then we want to assert that the balance after and the balance before are equal. If someone thinks there's something wrong here or something should be modified, say now or forever be silent.
I think maybe we should also take into consideration the underlying asset, because if we now put the from underlying asset to true, then the balance of the underlying asset will change, right?
So how would you check this? Would you check each assert separately, or would you check them both?
I don't know, maybe just an assert with the balance of the A tokens before and after should be the same, and then an AND statement. The balance of the underlying assets before and after should be the same.
So you're suggesting
That's what I was thinking, but two asserts or one assert with an AND, a logic AND.
Yeah, see, this is the same, and yes, you're right, because even if we're changing to underlying tokens, if this is what we expect to get, this is what we choose to withdraw, we still want the A tokens balance to stay the same. So we don't want to separate the two cases here. We definitely want to check both balances, no matter if we're from underlying asset or to underlying asset or to A token. So that's a good point. Any other suggestions for?
Maybe also,
yeah.
Maybe also the amount cannot be 0, because if you now call it with 0 amount, then it will probably work. The withdraw? No, I'm not sure.
Okay.
If you can call it with 0 amount.
Yeah. So suppose that amount is 0. What would you expect this function to do?
Either withdraw or do nothing with the balances, so it should be okay, I suppose.
Yeah, there's no reason to limit amount in any manner. If it was 0, I personally would expect it to revert. And of course, reverting does not change the balance. So even this case is well covered. Note that I haven't made any strong restrictions in this rule. My main thing here was setting the tokens, which is a thing we already agreed on. That doesn't change. It should be well defined, and that the recipient is the same as the message sender. So maybe some other people here would like to check this rule further. What happens if the recipient is not necessarily the same message sender? Maybe in some magical manner, I can withdraw for some other guy, and my token balance will grow, or his or her token's balance will grow. So this is not the most general rule I can write for this this example, but it's close enough. So bear this in mind, that whenever you're limiting the values of your function arguments, that you may not cover all possible cases. Any more modifications for someone? I don't see anything in the chat. Okay, so I guess you all agree on the implementation of this rule. I hope it was helpful. And I don't know, do we have any more time for more rules, more properties?
Roy, I maybe have one question. Would it be possible to make this rule a bit more broad by making it a parametric rule and saying that, okay, the balance after shouldn't change for any function except for the withdraw?
So this is a different rule, actually.
Including the withdraw, right? If it is not going to change for the withdraw, I guess, Zaf, is your question that can you replace the call to initiate withdraw with the parametric, the syntax, so that if your static balance is 0, no matter what function is called, your balance doesn't change?
Yeah, sorry, including the withdrawal. I was thinking we should exclude the deposit because then it can change.
Ah, yes.
But what if you deposit? Would your role be verified in this case?
Yeah, indeed, excluding the deposit. So for each and every method in the contract, the balances shouldn't change if you don't have any assets on L2 except for a deposit.
Mm-hmm. Yeah, it sounds reasonable to me. I would expect the same thing. You can completely write this, and I mean, this is a good implementation of the rule. It would be nice to check whether it's verified or not. Just bear in mind that you're just checking if the balance changes or not, but going further, you need to also check that it changes by the correct amount, given you're calling deposit or withdraw, right?
Yeah, exactly.
Yeah, and I believe that maybe this rule already exists, as been suggested in the chat. Feel free to modify the rules that were given to you, make them simpler or extend them. It's even better. So yeah, these are just examples, but you have the absolute freedom to suggest rules on your own. Norit, should we continue?
If there are more questions, we can continue for a few minutes, but otherwise we are available on the Discord.
Yeah, absolutely. Ask freely on Discord. I will share on Discord also this doc file writing what has been suggested here. So you'll have like a template for writing rules. And I would be glad to answer any questions if there are.
Sounds good. So shall I stop the recording? Or...
Thank you.
Yeah, I guess.
Yeah, I think there are, Roy, I think the examples that you've given in the existing spec file, I think there's like the integrity of withdraw. So, we can write similar rule for deposit as well, and maybe break that up into a couple of simpler ones. So those were the ones that I was looking at. But yeah, maybe we'll continue on Discord.
Yeah, sure. This is example is to give you like a model or a body of integrity functions. Definitely
Yep.
should be extended to deposit as well.
Yep. Thank you.